Whenever you're using your favorite app, have you ever stopped to think about what's happening behind the curtain? There's this hidden world of databases working like crazy to make sure your information is both completely safe and, available the second you need it. Today, we're going to dive into the two biggest challenges they face: keeping your data reliable and making things incredibly fast, even when you're talking about a massive scale.
Okay, let's make this real with a question that, let's be honest, affects all of us. You're transferring some money online. You type in the amount, you hit send. What's the invisible safety net that stops your money from just vanishing into thin air if something goes wrong halfway through?
So, on the surface, it seems super simple, right? Step one, the system takes 1,000 rupees from account A, but what if your internet connection suddenly drops, or the server has a little hiccup right at that exact moment, right before step two can happen? Now the money's gone from account A, but it never, ever makes it to account B. It's just, poof, gone. And that exact scenario, that's what engineers call the money transfer problem. It's the classic textbook example of a multi-step operation that absolutely has to either finish completely or not even start. There is no middle ground. I mean, not when your money is on the line, right? And the solution to this is a really powerful idea called a transaction. The best way to think of it is like a protective bubble you wrap around all those steps. It treats them as a single all-or-nothing thing. If every single step works perfectly, the transaction commits and the change is permanent. But if anything at all goes wrong, it rolls back and undoes everything. It's like it never even happened. No more lost money. So, how can these transactions make such a rock-solid promise? Well, they follow this famous set of 4 rules, and together they're known as the ACID guarantee. This is really the gold standard for making sure data stays correct and reliable. And that promise breaks down into this handy acronym, ACID. A is for atomicity. That's our all-or-nothing rule. C stands for consistency, which just means the database's own rules are never broken. Like, say, an account balance can't go below 0. I is for isolation, which is super important. It means if 2 transactions are happening at the same time, they can't mess with each other. And finally, D for durability. And this one's a big deal. Once a transaction is committed, it is saved for good, even if the whole system crashes 1 second later. And here's the really cool part. This brilliant idea isn't just for one type of database. It doesn't matter if you're using a classic SQL database like MySQL or a more modern NoSQL one like MongoDB. The core concept is exactly the same. Yeah, the commands might look a little different, but that fundamental flow of starting a transaction, doing your work, and then either committing or rolling back, that's totally universal. Okay, awesome. So our data is perfectly safe. Problem solved. We can all go home, right? Well, not so fast. What happens when your little app becomes a global sensation? Suddenly you don't have 100 users, you have 100 million. Now you're facing a completely different but just as massive challenge: the problem of scale. How in the world do you build a system that can handle that kind of traffic without just grinding to a halt? This is where we have to start talking about the different strategies for scaling a database. You've really got 2 main paths you can take here. The first is called vertical scaling. You can think of this as the more power approach. You just keep making your one server bigger and beefier, more CPU, more RAM. It's kind of like making one librarian incredibly fast. The other path is horizontal scaling, or the more machines approach. Here, you add a whole bunch of smaller servers and just share the work. This is like hiring a bunch more librarians. For pretty much all modern apps, this second path is the way to go. Okay, so we're going horizontal. We're adding more machines. But even within that strategy, there's a really critical difference in how you use those extra machines. And that brings us to a super powerful technique called sharding. So one way to scale horizontally is to just make a bunch of copies. Imagine you have 3 servers, and each one has a complete, full copy of the entire database. Then you have a sort of traffic director called a load balancer that just spreads all the user requests between them. This works great for handling more people who are just reading data, but you see the problem? Every single one of those servers still has to hold all the data, and that data keeps growing. Now, compare that to sharding. It's a totally different way of thinking. Here, an intelligent router sends each request to the right machine or shard. But here's the crucial part. Each shard only holds a unique piece of the total data. So for example, all the users with names from A to F might live on shard 1, G through P on shard 2, and so on. No single machine is stuck with the burden of the entire dataset.
So it's really important to get this. Sharding isn't an alternative to horizontal scaling, it's an advanced form of it. It's the strategy you reach for when your problem isn't just about handling more users, but about managing a sheer volume of data that's just physically too huge for any single computer to handle. So let's just boil it right down. Standard horizontal scaling duplicates data to handle more user requests, perfect for things like websites where most people are just looking at stuff. Sharding, on the other hand, partitions data to handle more actual data, which is absolutely essential for apps with gigantic, constantly growing datasets. All right, that was a pretty fast tour through the worlds of database reliability and scale. Let's just take a breath and pull this all together into the two most important things to take away from all this.
Honestly, it all boils down to two big problems, and they're two big solutions. Problem number one is reliability. The solution? ACID transactions, that all-or-nothing guarantee that keeps your data safe. Problem number two is scale. The solution? Horizontal scaling, and more specifically, sharding, distributing all that work across an army of machines.
And that leaves us with one final thought. As you're building or even just dreaming up your next project, you're always trying to balance these two massive forces. You have to have absolute reliability from day one, but you also have to be thinking about what happens if you succeed, what happens at a massive scale. So which one of those challenges do you focus on first? That's the constant and honestly the exciting puzzle of building things today.